Hello, this is Mrs. Sargent, and this is lesson 6.3, Writing Chemical Equations. So just a little bit of a review from our last lesson on balancing chemical equations. We have the chemical equation with sodium reacting with chlorine to form sodium chloride. Is this reaction balanced? Well, you should be able to tell me that no, it's not, because we have one sodium, we have two chlorine, and then on our product side, we have one sodium and one chlorine. So what do we need to do in order to solve this? Well, we need two chlorine, so we're going to put a 2 in front of sodium chloride. That's going to give us 2 sodium and 2 chlorine. So then we need to also put a 2 in front of sodium to get 2. Now we have a balanced chemical equation. So I'm going to review a little bit with you about naming. If you need further review, you definitely need to review your Unit 4 packet, the blue one, over ionic and covalent compounds, as well as come and see me to get help with covalent and ionic naming and writing formulas. Again, this is not going away, and the longer you wait, the harder it's going to be in order to understand this. So remember, covalent compounds is a nonmetal bonded with another nonmetal, or a nonmetal and a metal would. The prefixes indicate the number of atoms within a compound. Prefixes. And the second element is always going to end in "ide." We have the diatomic elements, which this is 2 of the same type of atoms bonded together. And I gave you a couple different ways to remember this. We talked about the Brinkelhoff twins: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. They're twins because when they're found by themselves, not bonded to something else, they are found in a pair. I also gave you the 7 to heaven. The 7 is the outline on the periodic table, starting with nitrogen. So on your periodic table, you have nitrogen, oxygen, fluorine, then chlorine, bromine, and iodine. It makes the outline of a 7. And then heaven is up top, up high, with hydrogen. 7 to heaven. Okay, so one of those two is you have to remember that anytime that these elements are not bonded to something else, they're going to be found with a twin. So we have CO2. We're going to name this carbon dioxide. Now we only have one carbon, and the prefix for 1 is mono, but we never use mono on our first element, so that's why it's just carbon dioxide. We have C2H6. This is going to be dicarbon, and the prefix for 6 is hexa, so hexahydride. And then we have phosphorus tribromide, so 1 phosphorus, no prefix, telling us we have 1, bromine, and it has 3. This prefix goes with the element it is attached to. And then we have nitrogen, which is N2, because it is one of our diatomic element, but when it's by itself, it's going to have a twin. Your ionic compounds is a metal and a nonmetal bonded together, or a polyatomic. Your ionic compounds are always going to start with a metal unless it starts with nitrogen and the ammonium, the only positive polyatomic that we have. The charges must be balanced in the chemical formula because our chemical formulas are neutral. If the metal is a transition metal, Roman numerals indicate the charge of that transition metal because our transition metals can have multiple positive ions. And an anion, which remember is a negatively charged ion, which is typically your nonmetals, is going to end with "ide." Or if your anion is a polyatomic, it's just going to be the name of the polyatomic ion. So we have K2O. Well, potassium is our metal, so it's going to be potassium. And then oxygen, but we're going to change the ending to "ide", so it's potassium oxide. We have CuNO3, so our metal is copper. Copper is a transition metal, so we know we have to have Roman numerals. NO3 is nitrate. Remember to determine the charge of your transition metals. There's an imaginary 1 there, indicating that we only have one of them. So if nitrate is a 1-, then this can go up for our charge for copper, which indicates that it is a 2+. Nitrate is a 1-, so we're going to go back and we're going to fill in 2 for our charge for nitrate. We have iron 3 sulfide, so iron is a 3+. Look at your periodic table. Sulfur is a 2-. So we're going to crisscross the numbers from the charges, and we're going to get Fe2, Fe2S3, and this is our formula for iron 3 sulfide. Then we have aluminum sulfate. So aluminum is a 3+, sulfate SO4, and it has a 2- charge. So we're going to crisscross the numbers. So this is going to be Al2. SO4 is going to be in parentheses because we're going to have more than one of them, and we're going to have 3. So that's your review for ionic compounds. Both of that should have been a review for you. Talking about acids, we have not yet talked about acids, so this is new. The cation is always going to be hydrogen, so your positive ion is always going to be hydrogen, and it is going to be bonded with a nonmetal or a polyatomic. So if an anion is a single nonmetal element, you're going to name it hydro, element name, but you're going to change the ending on that element name to "ic", and then add the word acid. So this is how it plays out. We have hydrogen, we have chlorine. So single nonmetal, so this is going to be hydro, chlorine, but we're going to take the ene off and add "ic", so hydrochloric, and then acid. We're given the name here, hydrofluoric acid. Fluoric is representing fluorine, so it's just HF. And if we balance out our charges, hydrogen is a 1+, fluorine is a 1-. Those balance each other out for this formula right here, HF. If the anion is a polyatomic, there's a couple different things that we're going to use for the rules for naming this. If the polyatomic ends in "ite", it's going to be the polyatomic name. But you're going to change the ending to "us", acid. And if it ends in "ate", ATE, it's going to be the polyatomic name ending in "ic", acid. Okay, so we have nitrous acid. So we're going to look at our periodic table. We need something that ends in "ite", which is going to be nitrite, which is NO2. So I'm just going to write down the charges of everything. We have hydrogen, which is a 1 plus, nitrate or nitrite, which is a 1 minus. So those balance each other out. So HNO2 is our formula for nitrous acid. Here we have hydrogen and we have SO4. We're going to look at our periodic table. SO4 is named sulfate. So this is going to be sulfuric acid. We're going to change the ending to ic. Notice both and 8 end with ic. Only your single non-metal are going to begin with hydro, though. Okay, so now I've given you some word equations, and we're going to take everything that we've taught to write a balanced chemical equation. So phosphoric acid. We don't have hydro, so it has to be a polyatomic. It ends in ic, so we said if it ends in ic, it has to be ending with a 8 in the polyatomic name. So this is going to be phosphate, PO4, 3 minus. Hydrogen is a 1 plus. So to balance this out, we're going to have 3 hydrogen and 1 phosphate. I always leave a blank in front so I have room to write my coefficients, because otherwise I don't leave enough room. Calcium is a 2 plus. Hydroxide, OH, it's polyatomic, has a 1 minus charge. So we need 1 calcium and we need 2 hydroxide in this formula. Copy down our yield arrow. Here we have calcium, which is still a 2 plus. Phosphate, which we said over here, PO4, 3 minus. So calcium, we need 3 of those. Phosphate, we need 2. And then plus, blank, water, H2O. Okay, so now we went from our word to our skeleton equation. We now need to balance this equation. So we're going to start by counting the number of atoms on each side. Well, we have hydrogen, and then we have phosphate in the reactants. We also have phosphate in the products, so we can count that as 1 unit. And then we have calcium. Hydroxide we don't have on both sides. We have to count the oxygen and the hydrogen separately. Well, we already have hydrogen here. 3 hydrogen. We have 1 phosphate. We have 1 calcium. And 3 hydrogen here, but we have 2 over here for a total of 5. In our products, we have 2 hydrogen. We have 2 phosphate. We have 3 calcium. And we have 1 oxygen. We only have to count the oxygens that are not in phosphate, because these oxygens are already taken into account by counting our polyatomics. So, let's start with calcium, because we need 3 of those. So we're going to put a 3 in front of calcium, to calcium hydroxide, to get 3 calcium. That's also going to give us 3 times the 2 oxygen that's there, which is 6. And then 3 times the 2 hydrogen for 6, plus the 3 here is 9. So 9. So 3 times 2 is 6. And then we have 3 here. So we need to then balance out our phosphate. So we need to put a 2 here. That's going to give us 6 hydrogen there plus the 6 there, which is 12. And 2 phosphate. So now our calcium and our phosphate are equal. We need to put a 6 here in order to get our 12 hydrogen, and then that also gives us 6 oxygen. Now everything is balanced, and we're going to put a 1 in front of calcium phosphate. In our next reaction, we have sodium iodide. I highly recommend writing out the charges so that you make sure that you balance your chemical formulas. So we need 1 sodium and 1 iodine and sodium iodide. Then we have copper 2 nitrate. That 2 is telling us that copper has a 2+ charge. Nitrate, NO3, 1-. So we need 1 copper, and we need 2 nitrate to balance that out. Copy the yield arrow, leave it blank. So copper still is a 2+. Iodide is a 1-. So we need to crisscross the numbers from those charges. So we have 1 copper and we have 2 iodine. And then here, sodium is a 1+. Nitrate is a 1-. So we need 1 sodium and 1 nitrate. Now we're going to count the number of atoms and polyatomics on each side. So we have sodium iodine, we have copper, and we have nitrate on both sides. So we're going to count that as 1. Sodium, iodine, copper, nitrate. So we have 1 sodium, 1 iodine, 1 copper, and 2 nitrate. Over here we have 1 sodium, 2 iodine, 1 copper, and 1 nitrate. So our iodine and our nitrate are unequal. So if we start here with balancing out our iodine, that's going to give us 2 iodine and 2 sodium. So then we need to put a 2 here to get our 2 sodium and our 2 nitrate. Now everything is equal, and we're going to go back and fill in with 1s. This is why it is very important that we write our balanced chemical equations in order to balance out our overall equation. So these last examples were word equations, but it kind of broke it down for you. The other type of word equation that we have seen is when it just describes the reaction in general. So this is solid calcium carbonate, which is in shells, reacting with hydrochloric acid to produce carbon dioxide, water, and a calcium chloride solution. I believe I have a typo in your packet. It says barium chloride. It should say calcium chloride. So we're going to start by writing out our chemical equation, our skeleton equation. So we have calcium carbonate. Calcium is a 2+, and carbonate, CO3, 2-. So we need 1 of each of those. So CaCO3. We're told that it is solid, so we're going to mark that with an S. If you're given the states of matter, you need to write it. If not, then you can omit it. When it says reacts with, that's where we're going to write the plus sign. Hydrochloric acid is HCl, single nonmetal acid, beginning with hydrogen. All of your acids are always going to be a solution. And so our solutions, we mark AQ for our state of matter. To produce, that's where we write our yield arrow. Carbon dioxide, so that is CO2. And carbon dioxide is gas. It's something we breathe out, so we're going to mark that as gas. Water is H2O. And we said that water is always going to be liquid unless you're told that it is a water vapor. And then calcium chloride, so calcium is still a 2+, and chlorine is a 1-, so it's going to be CaCl. Cl2. So now we need to go through and we need to balance it. We have calcium. We don't have carbonate on both sides, so we need to do carbon and oxygen by itself, and then hydrogen and chlorine. So we have 1 calcium, 1 carbon, 3 oxygen, 1 hydrogen, and 1 chlorine. So over here we have 1 calcium, we have 1 carbon, we have 3 oxygen, 2 hydrogen, and 2 chlorine. Okay, so let's start by looking at our chlorine. So we need to put a 2 here. That's going to give us 2 hydrogen and 2 chlorine. So those are balanced out, and oxygen is also, and so now everything's balanced. We're going to go through and fill everything else in with 1s. So this is taking and putting everything together. Next class, you will have a homework quiz over writing and balancing chemical equations. You will not be given any skeleton equations. You will have to write out your skeleton equations from the word equations and then balance it like we just talked about. Go ahead and work through the practice, and if you have any questions, come and see me. Thanks. Have a great day.